Hey guys, welcome back to chapter 17. What we're going to do today is look at data and be able to predict or determine what order a reaction is. So just as a reminder, the orders that we are going to deal with, we're going to have zero order, first order, second order. Zero order is when the concentration of the reactant is independent of the rate. So we could increase, we could decrease the concentration, rate's not going to change. For first order, it's directly proportional. So if I double the concentration of A, the rate is going to double. If I triple the concentration of A, the rate is going to triple. And then lastly, we had second order. So second order is proportional to the square of the concentration. So if I double the concentration, rate's going to go up by a factor of 4, 2 squared. If I triple the concentration, the rate's going to go up by a factor of 9, 3 squared. So now let's look at some data and see if we can predict whether a reactant is zero, first, or second order. So it can only be determined experimentally. We can't look at a reaction and just figure it out. We have to look at the data. So this is going to be kind of the data that we're going to look at for the next 3 slides. So the data is this. Here's our concentration of A, and we're going to increase the concentration of A from 0.1 molar in trial 1 to 0.2 molar in trial 2 to 0.4 molar in trial 3. So we're just increasing the rate as we do different trials. And then for each trial, we are going to measure the rate. So the rate's going to be molarity per second. So each trial will have a rate associated with it. So to determine the rate of this reaction, we're going to compare 2 different trials. Doesn't really matter which trials you choose, but just pick 2. So maybe I'm going to look at trial 1 and trial 2. So what happens to concentration of A between trial 1 and trial 2? So the concentration of A doubles. Now we're going to look at what happens to the rate between trial 1 and trial 2. So what do we notice about the rate here? It also doubles. Yeah. So we double the concentration, rate doubles. What order is this? Yeah, it's first order, directly proportional. So in this particular experiment, the reactant would be a first order reactant. So this is first order. If you are not just inherently seeing these as I talk through it, we are going to have a systematic formula to determine the rate of the reaction. So just hold tight on that. We will have a systematic formula to determine these. All right, so now we're going to look at a completely different experiment. It's still going to say A. Let's pretend like it's something different, okay? So completely different experiment, completely new set of trials, and see if we can determine the order of this reaction. All right, so same thing going on here. As we go from trial 1 to trial 2 to trial 3, we're increasing the rate or the concentration of A, and then we take the rate of each of those trials. So first, let's look at the concentration of A, and let's pick 2 different trials just for funsies. So let's pick trial 1 and trial 3. Let's pick these 2 just for funsies. So between trial 1 and trial 3, what happened to the rate? So in this case, the rate went up by a factor of 4. So up by times 4. Okay. Now let's look at trial 1, the rate for trial 1 and trial 3. What happened to the rate for trial 1 and trial 3? Nothing. It stayed the same. So what order would the concentration of A go up by a factor of 4, but the rate stays the same? Yep, 0 order. So this is an example of a 0 order reaction. It doesn't matter what the concentration of A is, the rate stays the same. 0 order is by far the easiest one to recognize because the rates are the same. You look at 2 different trials and you're like, the rate didn't change. That's a 0 order. So this is by far the easiest one to identify. All right, last example here. All right, so again, across the trials, trial 1, trial 2, trial 3, concentration of A increases. We take their rates for each of these. This one's a little bit harder to see. So let's look at trial 2 and trial 3. I'm just trying to get you used to looking at something other than 1 and 2. So trial 2 and trial 3. So let's look at the concentration of A here. So from trial 3 to trial 2, what happened to concentration? Yep, it doubled. It went up by a factor of 2, or doubled. Right? 0.4 to 0.2. That's double. All right, what happened to the rate here? Okay. So the rate for trial 3 was 0.24. The rate for trial 2 was 0.06. What is the difference between those two? So it is a factor of 4. It quadrupled. So 6 times 4 is 24. So it quadrupled. So what order would we double the concentration and the rate quadruples? That's a second order reaction. Yeah. All right, so what if you just didn't inherently see this one? Second order is by far the hardest one to see. And then sometimes even for a first order, things aren't as clean cut as you would like them to be. So how could I predict that this was second order if I didn't just see it, if the numbers weren't really pretty? So we're going to look at this same group of data, but we're going to put a formula out there. So here's the formula. The formula is going to take the concentration of trial 2, right? It doesn't matter if it's 1 and 2, it could be 2 and 4, whatever. But the concentration of trial 2 over the concentration of trial 1 raised to the y, and that's going to be set equal to the rate of trial 2 over the rate of trial 1. Biggest mistake that students make is not matching up or lining up trials. So if trial 2 is on the top, rate of trial 2 is also on the top. If concentration of trial 1 is on the bottom, rate of trial 1 is also on the bottom. So that would be my biggest tip here, is make sure your trials are lined up. And what we are solving for in this case is we're going to solve for y. And y is going to equal the order. So if y equals 0, 0 order. If y equals 1, first order. Y equals 2, second order. So that's what we're going to solve for. Okay. So let's plug in the data and let's stick with the trials that we were looking at here and here. All right, so I always put the bigger number on top. It always equals out to whole numbers rather than decimals, and I just prefer that. So I will always put the bigger concentration on top. So I'm going to put concentration of trial 3 on the top, so 0.4, divided by the concentration of trial 2, which is 0.2. And then that's raised to the y. Now I'm going to put the rates over here. So I put trial 3 on the top. So I need to make sure I put the rate that matches that on the top. So I'm going to put 0.24. And then I'm going to put the rate that matched up to 0.2 on the bottom, 0.06. So now let's just clean this up a little bit by throwing it into our calculator. So 0.4 divided by 0.2, that gives me a value of 2 raised to the y. And then 0.24 divided by 0.06, and that gives me a value of 4. Now, from here, if you can see what y should equal, you could just say, oh, 2 to the 2 power equals 4. So if you can see it from here, then you can just say, yep, y equals 2. This is a second order reaction. That would be fine. But again, if things are messy and I can't just see it from here, let me teach you how to algebraically solve for y. To get that y down, we do an algebraic trick that you probably never thought you were going to use, but we take the log of both sides. I'm going to move this over so I can take the log. So the algebraic trick here is I'm going to multiply both sides by log. What that does is it will bring this y value out of the exponent. So what we'll have on the left-hand side here is y times log 2 equals log 4. There was no exponent here, so that's why nothing comes down. Now I simply plug this and this into my calculator. So y times, so in my calculator I'm typing log 2, and that is 0.301. And now in my calculator I'm typing log 4, and that is 0.601. And now to solve for y, I just divide by 0.301, divide by 0.301, and then we'll get, I'm going to bring it up here, y equals, so I'm going to type this into my calculator, 0.601 divided by 0.301, and it equals 1.99. Round that up to a whole number. So y is always going to be a whole number. It's going to be 0, it's going to be 1, it's going to be 2. So if my calculator spits out 1.99, I would round that up to 2. So for the third time, we have determined mathematically that this is a second order reaction. That's your introduction to looking at experimental data and determining the order of the reaction. In the next video, we're going to look at some more data, an actual chemical reaction, and we'll determine what the orders are. I hope you guys found this helpful.